Welcome back everyone to another video and a very special piece of equipment that is on the bench today. This is probably one of my biggest investments in the sort of home shop environment, the test equipment sort of thing. This is my sort of next step, I guess, to try and improve what I do in regards to restoring amplifiers and audio equipment in general. It's not enough to just throw parts at amplifiers and whatnot. We need to know that what we're doing is making an actual difference and we're actually improving it, or we're not harming it. And we need to be able to load amplifiers with dummy loads to test their power output, but we also need to be able to measure what they're outputting to see if it is something that is acceptable or within specifications for what that equipment was intended or it was originally supposed to be able to perform at. So this brings in equipment like this made by ShibaSoku. This is an AM50 audio distortion analyzer, and it is quite the impressive piece of kit from 1995, I believe. The sort of general idea around one of these pieces of equipment is it will generate a sine wave, which we can program over here. We will feed that out of this unit and we will feed it into an amplifier or whatever piece of equipment we happen to be working on, and then feed the output of that equipment back in, and we can sort of null out what this is putting out and what is coming back, and the difference between the two we can use to work out things along the lines of total harmonic distortion, phase, voltage levels, just general noise. Well, this one doesn't do noise specifically, but where there are filters available where we can block out harmonics and things like that. And there are many other features here that we'll probably dive into at some point in the future when we go down the rabbit hole. But these pieces of equipment may be relatively common in places like the US, but in Australia they are incredibly rare. These do not come up often. When I saw it listed online, I put an offer in and it was accepted, and I had to buy it because I don't think I'll see another one in many years, if even that. So here it is. But it is still an old piece of test equipment, and we need to go through it and have a look at what it's doing at the moment and if we see any issues with its performance. So I'm going to just set up a couple of things and I'll show you a couple of observations I've found so far. We're going to pop the lid and then we're going to have a look at what's inside this thing. And work out where we go from here and how this is going to be part of my restorations going forward. So let's get started. All right, so the unit is set up. Basically what we have here is balanced connections coming out of the internal oscillator and coming back in for analysis. Over this, so it's sort of split down the middle. And if we go into the frequency at the moment, we can see we've got it set to 1 kilohertz. The amplitude is 5 volts. I'm going to drop it to 4 volts at the moment. Now, I am noticing something that's a little bit unusual. What I would expect from this unit if it is performing correctly. I could be completely wrong about this. I am over my head. I just want to make that clear. But I would expect both channels to track the same if they have the same settings, which is not what we are seeing at the moment. So the oscillator's pretty close, 3 decimal places. But we're looking at the distortion figure here, which is basically reading directly off the oscillator. We're seeing very, very low number, obviously, but if we switch to channel B, suddenly we're jumping up quite some margin, and that is something I'm a little bit concerned about. And what is interesting is if I change the loading, what will happen is it will disappear. And then if we switch between the channels, we're finding that it's pretty much back to normal. Very close anyway. And if I turn that back off again, suddenly our distortion comes back. And what is also interesting about this is if I change the amplitude, so we'll go up to 5 volts now, we're going to see the inverse of this happen. So now that distortion is gone, and if I turn the load on, now it comes back. So it's a little weird. Something is going on, and I'm not completely satisfied with what I'm seeing here, because I want to trust all the equipment I have, and we don't know where this value is coming from. So I pondered for a little bit about how I can try and diagnose this before we crack this unit open, and I am going to use an external DAC, feed a signal from my DAC into this unit, see if the same issue happens or it disappears, because that'll tell us if it's in the oscillator or if it's in the other section, which is doing the actual analysis. So my DAC can put out around 3.5, 4 volts. So I'm going to just go with like 3.7 volts and see what we're looking at. Turn off that loading again. So we're still... No, now it's doing weird things again. Now it's jumping again. This is interesting. At 3.7, and this isn't a big change from 4 volts. So now it's gone. And if I go to 4 volts, now it's gone completely. Look at that. Or is it back? No, this is not right. Where it's doing some weirdness. And this could be me learning how to use this thing as well. I'm not an expert. I still have to wrap my head around this piece of equipment without a manual, because there is no manual available for this specifically. It is pretty straightforward with its layout, other than the filters and everything. But yeah, I'm not liking what I'm seeing at the moment. It might not be anything to worry about, because this is a very low current signal just coming out of the oscillator. But let's switch over to an external DAC and see if something changes. Alright, so I've got balanced outputs coming from my SMSL SU9 Pro DAC. I don't care what anyone says, these Chinese DACs are really impressive units. It is probably a better oscillator or signal generator than what is in here for this day and age. We don't want to use it, obviously. We want to use this because this is the reference point for what it's going to be measuring, but we can at least do a comparison of what this DAC can do with an audio generator that I've got set up on the computer. Now, as you can see, I am not using the internal oscillator. I've got it set to 2 kilohertz at the moment, and we are seeing bang on 1 kilohertz, and that is because that signal is coming from this DAC. If I change this to say 500 hertz, we are bang on 500 hertz. So we have confirmed that the signal is coming from here, not from the internal oscillator. And we're on channel A, and we can see that the distortion is basically where it's been sitting every other time. And we switch to channel B, and the 0.03 is peeking its head again. So it does not appear to be the oscillator inside this unit that is the source of this deviation in number. I am changing the level. So because we have a volume control on here, we can change the voltage and dial it up. So it maxes out around 4 volts, like I said, and the distortion will be back where it was. Now, if I start to turn it down a little bit and change that voltage, I have a feeling it may disappear again. Maybe. Oh, there we go, it's gone. Interesting stuff. Now, I have also confirmed that it is frequency dependent, so if we change to something like 5,000 hertz, it does tend to disappear also. So it is a very specific region of this unit where this change seems to happen. We need to keep this in perspective. We're still talking about a very low distortion number, but some of the amplifiers that we're probably going to test on this thing, it can push THD figures down into this range. So I think we need to keep that in mind. And we can also turn on all the filters. And I'll put it back to 1,000. And they're not really making any difference. So obviously this isn't referenced or nulled out with this, but it's so clean already that it's basically a reference point that we can use for testing. Okay, so I had to take a step back for a bit off camera and just get my thoughts together. And the more I'm working with this thing, the more I'm seeing problems and things that don't give me the warm fuzzies about trusting this unit, and I think we have a lot of problems to deal with. So I decided to go back, and I was also looking at the voltage that the oscillator is putting out versus what it's reading, and we can see that this is very, very wrong. Now, this is a balanced output, so we should be seeing double what the oscillator is, and we are 8 volts. So the voltage that the oscillator is putting out is behaving correctly. And we can also see if I turn off balanced, it drops to 4 volts, which is very close to what we should be seeing here. This is not correct. So we have problems here, either in the display or something around the input section. Who the hell knows? I'm still trying to wrap my head around this. This multimeter can do frequency also, which is fantastic. 998 hertz, 998 hertz. So this display, very accurate. The oscillator, accurate. Not perfect, but reading correctly. So good, bad, everything in between. So I decided to set up my Quantasylum again, which I really don't like this thing. I hate their software. I hate their support. I have to use this crappy old laptop to make this thing work because they've cut off all the USB drivers and everything, but that's another rant for another day. But anyway, we can see the 1 kilohertz signal coming through. It's clean. There's no harmonics after it. It is what it is. It is the same on both channels. No problems there. Now, if I switch this over to distortion, I believe what it is trying to show on the monitor output is the result of all the nulling and the it's just showing sort of residual noise and harmonics from the channel itself. So we can see that the primary signal, the 1 kilohertz signal, is gone. But if I switch this across to channel B, something is going on here. We can see that the 1 kilohertz signal is present and seems to be leaking through somehow, or it's not being nulled out. I'm not sure exactly what it is. And we're also seeing harmonics in there, spikes, just a lot of junk. And it also explains why this is jumping around as opposed to channel A, which is relatively stable most of the time. Anyway, I thought that'd be important to share. Moving on. All right, so lids off. I've taken off all the panels and everything. I just want to be super clear because I know someone's going to say this in the comments. Yes, I swapped all the cables around, all the connectors around. It is not a connection. Well, not a cable issue. I mean, it could be the connectors in the front here. I don't think so, but I've swapped all the low-hanging fruit and tried all the easy stuff, and it's not that. Anyway, looking inside this thing, wow. Japanese craziness. Whoever designs this stuff blows my mind. Like, how you can come up with designs like this, like the complexity that's in this thing is just staggering. There are adjustment trim pots everywhere. We've had a service manual and some very, very specific equipment and jigs. I doubt you can do anything with these units. They are all labeled nicely enough, but you're touching anything in here? Wow, I don't know. I can't see myself going anywhere near any of this. But anyway, what are we looking at? What is the sort of low-hanging fruit that we can have a look at without any risk and possibility of success? Well, there are some electrolytic capacitors floating around in some of these cards. There's not a lot of them, but there are some present. And we can have a look at those. The odds of them being bad are not high, but it's something that we need to at least consider. The other thing that I am really suspicious of is this racking system with all the PCBs. It means they all drop down and lock into a main board, and that means there's like card fingers on the PCBs and sockets down the bottom for all of these cards. And they can be prone to oxidization, intermittent contacts, impedance changes, all sorts of things. And in regards to physical things, we're also looking at relays, and I'm not really seeing, I don't know what these are. These look suspiciously like optocouplers. But over here, I'm definitely seeing some micro relays, I'm pretty sure, right down the bottom of these cards. We are going to pull every one of these cards and go through it. And I think we're going to clean all the mechanical, physical contacts and start there and see what happens. I have tried moving the cards around a tiny bit, and I'm not seeing anything that is standing out. Now, all these trim pots are most definitely labeled, but my God, would you really want to mess with any of this? I don't think so. These are, I thought these were precision resistors, these big silver barrels, but I believe they are capacitors, and I really want to see what sort of capacitors these are. Looking at the silk screening, it does say C, so that would imply a capacitor, but it is something quite special by the looks of it. I am seeing a backup battery, memory battery in here. Does this hold calibration data? I don't know. I don't think so with the amount of trim pots this thing has. I think it just holds the memory storage for presets on the unit, but we need to deal with that. These batteries are ticking time bombs for other gear I've seen with computers and whatnot. They will leak and they will destroy the boards. So that needs to be addressed also. I may pull that out and get that ordered before we go down any deep rabbit holes. But I think we'll start with pulling the cards and whatnot. And we'll have a look at this power supply at the back. I'm going to flip this around and I'll just show you the back briefly, and then we will close out. Okay, so looking at the back, this thing is completely passive. There's no fans in it, which is absolutely fantastic, especially for vintage gear, because I've got some HP power supplies and other things from the same sort of era that drive you nuts. The fans are really, really loud, and they're just a nightmare to put up with when you're trying to film or just work sort of thing. And all this is coupled to everything directly inside, so that's a really nice thing to see. IEC connector, removable power cord, excellent. Multi-voltage, supports every voltage as far as I can tell, which is excellent as well. Inline fuse holder, grounding tie, certification stuff, and a bus interface, which I know absolutely nothing about. The power supply is the last thing I wanted to show you. There is a noise suppression filter here, just there, which is nice to see. And this is just the main power supply section here, and I believe this is some sort of a shielded transformer. Looks like it's probably potted inside as well, which comes out and then into this board here, which I found very interesting. There's a lot of capacitors in here, electrolytics specifically. I am seeing the mark of the devil, which is Matsushita capacitors. They're made sort of, I think that's Panasonic name. They're generally okay, but I've not had the greatest experiences with their capacitors. So I would like to change all of these electrolytics. The only issue I foresee is they are axial, and getting good axial capacitors these days is not as common. Most are radials, and so we'd have to hunt around a bit there. Interesting design though. It appears that the transformer has multiple taps coming out for different rails, and then there's an independent rectifier for each rail. So I can see at least 4 rectifiers down there. And if I'm looking at this correctly, it then moves across to one stage of filter capacitors, and then there's another stage of filter capacitors. I am also seeing some coupling capacitors by the looks of it on the very end there. And there's some resistor networks in there as well for God knows what's going on, noise or just bleeding them. There are some big power rectifiers at the back here as well, and some transistors or regulators of some sort, which I have no idea until we get in and I'll look up some part numbers and see what's going on in here. Yeah, pretty nice, very, very highly engineered unit, but it is still from 1995, so what are we doing? We're pushing 28 years old, and electrolytics age, and this back bit gets really hot. So heat plus electrolytics, bad. We need to definitely look at that section and check the rails as well. So I think I'm going to leave this video here. This is just a bit of an introduction. In the next video, I think we will take out all the boards, clean the connectors. We'll do an audit of what's actually in here with capacitors and that battery. Get a game plan on what we're going to replace or not replace or leave alone. I have no idea at this point. We'll learn together. I don't know what the hell I'm doing with this unit, and I imagine most people at home have no idea. If you happen to have worked on one of these as a service tech in the past life, feel free to chime in, because there are no service manuals, there are no user manuals, there are no nothing for these things from what I can tell. So we're flying blind here, and we will just take it one step at a time and see what happens. Hope you enjoyed the video, and we will be back with another one soon. See you then.